Hello, welcome to Algebra 1 with Miss Andrea. Today we're going to continue learning about statistics, and our unit is called Describing Data. Now this is in the online book. It is Module 8, but it is called Unit 6A. And the descriptor of the unit, the title of the unit is Describing Data, and we're on page 3, so this is lesson 3. Now, getting into our data here, the first thing we want to talk about today is called measures of dispersion. Dispersion means how it's all spread out, how it's dispersed. So there's two common measures that we want to get into, just like when we had two main ways to measure center of data. We have two main ways to measure the dispersion or the spread outness of the data. So the first one is the range. Now remember, we already have talked about range a few times. Range is the difference of the largest value minus the smallest value. Now, if you remember, I'm going to draw just right on top of these words here. When we had a graph, let's say an exponential graph, right? The exponential graph, we had domain and range. Domain was the x values, all possible x values, and range was all possible y values. So from the lowest possible value, so this couldn't get past 0, right? But it went to infinity. So the range was from 0 to infinity. So range in our data is going to be very similar, except is not specific to just some y values, because our data is going to be a list of numbers. So your range is all the possible, it's going to include all the possible numbers. And the way that you include all the possible numbers, just like on the graph, you listed it from least to highest, we're going to take the least and the highest value and find the difference between them. And that's going to be our range for our data. So in statistics, a range is a little bit different than it is in algebra when you're looking at graphs and things like that, because it has to do with the y value, but it's still the same concept. It's the total amount of possibilities for something, right? So then interquartile range, we still have that same word range there. So we just have to really focus on, well, what does interquartile mean? Well, if you remember from our vocabulary video, interquartile range meant, well, we had, oops, I thought I was on eraser. We have 3 quartiles. The middle one is the median, right? And you've got data, 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 quartile 1, data, 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 quartile 2, data, 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 quartile 3, and some data at the end, right? Quartile range is this area right here in the middle. So they want to know what's the range between the third and the first quartile. So what does that mean? Well, that means whatever your quartile 3 is, you're going to subtract quartile 1. So quartile 3 minus quartile 1 equals our IQR, interquartile range. Okay, so that's how you find IQR. Whereas regular range is your maximum minus your minimum. All right, so now we've got some practice problems for you. I want you to go ahead and pause the video and figure this out on your own. Welcome back. All right, so here we've got this data. The very first thing we need to do is put it in order from least to greatest. So I've got 1, 1, 2, 2, 4, 5, 6, 7, and 8. 6, 7, and 8. All right, I've got them all there. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9 sets of data. 1, 2, 3, 4. 1, 2, 3, 4. So this is my median. So then to find my quartile 1 is going to be in between these two. So it's going to be 1.5, and quartile 3 is going to be in between these two. So it's 6.5. So The range is going to be my maximum, which is 8, minus my minimum, which is 1. So my range is 7. My IQR, or interquartile range, is going to be Q3, which is 6.5, minus Q1, which is 1.5. And that's going to be 5. So range is 7, IQR is 5. Find the range and IQR of this data set. Okay, well, let's put them in order. I've got 5 and 6. 7, 8, 9, 10, 11, there's 12, and 13 and 14. Then 17 and 18. And then, oops, I missed an 11. It's going to go right there. And then I've got 20 and 21. All right, so let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Halfway in between is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so my median is going to be 13.5. Then halfway between these, 1, 2, 3, 4, 5 is going to be 18 is quartile 3. 1, 2, 3, 4 right here is my 11. I'm glad I didn't forget it, is quartile 1. All right, so my range is going to be my largest number, 21, minus my smallest number, 5. Is 16. And then my IQR is going to be quartile 3, which is 18, minus quartile 1, which is 11, and that's going to be 7. So range is 16, IQR is 7. All right, the greater a measure of spread is, the more spread out the data is. Well, that just makes more sense, right? The higher your IQR or your range is, the more it's spread out across, it's dispersed, measure of dispersion, right? Across information. So these measures of spread are indicators of consistency. The smaller the measure of spread, the IQR or the range, the more consistent the data is, right? Whereas a larger spread would be less consistent. So we've got 2 students here, Tom and Lisa, and these are their test scores. And we're supposed to find the mean and the range of all of their test scores. Okay, now remember, what does mean mean? Well, mean means average. So we're going to add them all up. 90 plus 90 plus 80 plus 100 plus 99 plus 81 plus 98 plus 82 is 720. And then I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8. And my mean for Tom is 90. So X equals 90, X with the line over it, bar X, X bar, excuse me, which means mean. Mean is 90. All right, so we're going to find the mean of Lisa's. 90 plus 90 plus 91 plus 89 plus 91 plus, let's see, 89 plus 90 plus 90 is 720 divided by 1, 2, 3, 4, 5, 6, 7, 8 divided by 8 as well is 90. So I got the mean of 90 as well for Lisa. So what's the range? They have the exact same mean, the center of the data, right? Mean is a measure of center of data, just like median is a measure of center of data. Okay, but that doesn't tell us too much. That just tells us what the average is. How can we tell which student is more consistent in their work, meaning they generally get the same grades all the time? Well, the best way is going to be the measure of spread. So we're going to look at the range of these scores. So for Tom, we need to take his highest test grade and subtract his lowest test grade. I think that I got those correct. 100 minus 80 is 20. So his range is 20. But with Lisa, let's see, 91 looks to be her highest, but her lowest looks to be 89. So 91 minus 89 is only going, oops, I didn't put that in correctly, is only going to be 2. So with a range of 2, we can see that Lisa is much more consistent with her work and consistently studies and knows what she's doing and is able to get good grades. Whereas Tom, his grades vary, right? They vary between B's and A's. Some material is easier for him. He can get 100. Some is a little harder. He can get an 80. Okay, but Lisa is going to be the more consistent student, meaning her grades are more consistent. She performs consistently on the tests. All right, so the next thing we need to learn about is mean absolute deviation. And this has so much work, it makes you mad. Mean absolute deviation, MAD, mad. Okay, now, just because something is long or a lot of stuff to do, a lot of steps, does not mean it is difficult. Long and difficult are two different things. You need to be aware of that. Everything that you do in statistics is going to be not difficult, but there are many things in statistics that become long, okay? So mean absolute deviation. We kind of went over this a little bit in the important terms video, key terms video. Mean is going to mean the same thing, average. The average of what? The average of the absolute deviation. Absolute means absolute value, okay? That means we're not going to have any negatives. You're going to use those absolute value bars. Deviation is going to mean difference from the mean, okay? So we have the list of Tom's test scores here. And remember, his mean was 90, okay? These are all his test scores that we averaged together to make 90. And so how we find the mean absolute deviation is we have to subtract each of these test scores from the mean and find them with the absolute value. So we're going to have the mean minus the test score. Okay, so mean is 90 minus the test score is 90. 90 minus 90 is 0. The absolute value of that is 0. Same thing here, exact same answer, right? 80, okay? The mean was 90 minus the test score of 80, absolute value, and we're going to get an answer of 10. Uh-oh, this one doesn't have an answer. I guess we need to figure it out. 90 minus 100 is negative 10, but we have the absolute value of that, which is going to be 10. 90 minus 99 is negative 9, but the absolute value of that is 9. 90 minus 81 is 9. 90 minus 98 is negative 8, but the absolute value of that is 8. And then 90 minus 92 is negative 2. Absolute value of that is 2. Now, we did the absolute deviation part of it. You see it says absolute deviation, but we have not done the mean part of it. Do you remember what the mean is? The mean is the average. So we need to average all of these absolute deviations. So we're going to add them all up first. 0 plus 0 plus 10 plus 10 plus 9 plus 9 plus 8 plus 2 equals 48. And then we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8 is 6. So the mean absolute deviation is 6. I added them all up. I summed up all of the absolute deviations and I divided by 8, and that gave me 6. That's the mean absolute deviation. See, it's easy. It's just long. Now, I've got some practice for you. Go ahead and pause the video. Do these on your own. Welcome back. We need to find the mean absolute deviation of this data. So the first part of that is we need to find what the mean is of the data. So 4 plus 2 plus 1 plus 8 plus 1 plus 5 plus 7, plus 2 plus 6 is 36 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 pieces of data. 36 divided by 9 is 4. So the mean is 4. So now I'm going to take this mean and subtract each one of these numbers. 4 minus 4 is 0. Okay. 2 minus 4 is negative 2. The absolute value of that is 2. 1 minus 4 is negative 3. The absolute value of that is 3. 8 minus 4 is 4. 1 minus 4 is negative 3. The absolute value of that is 3. 5 minus 4 is 1. 7 minus 4 is 3. 2 minus 4 is negative 2. The absolute value of that is 2. And 6 minus 4 is 2. Okay, now we need to add up all of those absolute difference. I don't think it's called difference, absolute deviation. We need to add up all those absolute deviations, all those deviations. So 0 plus 2 plus 3 plus 4 plus 3 plus 1 plus 3 plus 2 plus 2. And then that got 20 there. I'm going to divide by 9. And so my mean absolute deviation is 2.2 repeating. Find the mean absolute deviation of the data. First thing we need to find is the mean. 11 plus 17 plus 20 plus 5 plus 12 plus 18 plus 6 plus 21 plus 13 plus 14 is 137. Okay, now we need to find the absolute deviation. Oh, that's not one. That's what they added up to, but I need to divide that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 pieces of data. So 137 divided by 10 is 13.7. All right, so now we need to subtract our data from the information we have there. So 13.7 minus 11 equals 2.7. If you notice, with number 1, I took the data and I subtracted the mean, and then I put the absolute value underneath. With this one, I'm taking the data, I'm taking the mean and subtracting the data and putting the absolute value underneath. It does not matter which one goes first when you're subtracting if you take absolute value. Okay, so you can do whichever order you want. So 17 minus 13.7 is 3.3. So in this case, I'm going to alternate between whichever number is larger and subtract that. That way I can always have an absolute value. So 20 minus 13.7 is 6.3. 13.7 minus 5 is 8.7. 13.7 minus 12 is 1.7. 18 minus 13.7 is going to be 4.3. 13.7 minus 6 is going to be 7.7. I'm going to put that down here so I can have more room. 21 minus 13.7, 7.3. 13 minus 13.7 is 0.7. 14 minus 13.7 is going to be 0.3. All right, now I need to add these together. So 2.7 plus 3.3 plus 6.3 plus 8.7 plus 1.7 plus 4.3 plus 7.7 plus 7.3 plus 0.7 plus 0.3 equals 43. And I'm going to divide again by 10 because there's 10 pieces of data. So my mean absolute deviation is going to be 4.3. Outliers. Now, we kind of spoke briefly again in the key terms video about what outliers are. They're the things that are way out there. So that was a very general definition. Here we have some formulas for us to help us determine without a shadow of a doubt if something is an outlier or not. So something is an outlier on the lower end of the data set if it's less than whatever your quartile 1 is minus 1.5 times the interquartile range. Remember, the interquartile range was Q3 minus Q1. So we can rewrite this like this. X is less than Q1 minus 1.5 times Q3 minus Q1. Okay, and it's the same thing for the upper end of the data as well. It just, you flip the inequality symbol, so it's greater than here instead of less than. So here we're going to look at this data set, and we're going to determine if it has any outliers. The first thing we need to do is put this in order from least to greatest. So there's 2, and then it looks like 11, and then 12, and then 13, 14, 16, 17, 18, 20, and 21. All right, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So our median, which is quartile 2, is going to be 15, because 14 plus 16 divided by 2 is 15. So 1, 2, 3, 4, 5 pieces of data. So this is 12 is quartile 1. 1, 2, 3, 4, 5. So this right here is quartile 3, right? So now we need to look for if the data set has any outliers. The only thing that I think could possibly be an outlier is 2, because the rest of these are all kind of close together, but 2 seems to be rather far apart. So that's on the lower end. So I'm going to specifically look at this formula. If it was on the higher end, I would use the opposite formula. So what I'm going to do is see if this statement is true. I'm going to put 2 where the X is, because that's what I'm looking at. And I'm going to have a less than. Now the next thing I'm going to fill in is quartile 1. What is quartile 1? It's 12. Okay. And then in my parentheses, then I have minus 1.5 times. And then in my parentheses is IQR, which I happen to know is quartile 3 minus quartile 1. So quartile 3 is 18 minus quartile 1 is 12, close parentheses. So now all I'm going to enter into my calculator is going to be this side of the inequality. Okay, so I'm going to put 12 minus 1.5, open parentheses, 18 minus 12, close parentheses, and hit enter. So once I've done that, I get 3. Now, is 2 less than 3? If this is a true statement, then 2 is an outlier. If it's a false statement, then true is not an outlier. In this case, 2 is less than 3 is a true statement. So 2 is an outlier. All right, practice. Pause the video, do these 2 problems, and I think this is the last topic for this lesson. So let's give it a try. Welcome back. Let's put this data set in order. 13, 14, 15, 16. Oops, why am I going to cross out the bottom? Ooh, there were 2 15s. Let's put another 15 down there. 15. I already crossed out 16, 17, and 21. If there's an outlier, it's going to be 21, I'm pretty sure. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I just didn't cross off my 21. Halfway in between that is 15. That's going to be my median, also known as quartile 2. Halfway in between that, 1, 2, 3, 1, 2, 3. Halfway in between that is quartile 1, which is 14. Halfway in between the upper end is quartile 3, which is 17. All right, remember my formula was X is either greater than or less than quartile 1 minus 1.5 times quartile 3 minus quartile 1. You know what? Let me go back a second. It's plus or minus. That's what I thought, but I wanted to be 100% sure. It's plus or minus here. So with this less than, you would do minus. I'm going to put that underneath. So with the less than, you would do minus, and with the greater than, you would do plus. Okay. So in this case, since 21 is on the higher end, on the upper end of the data, I'm going to fill this out with the greater than. So quartile 1 is 14. And then I'm going to, because I use greater than, I'm going to use plus here. Matter of fact, let me go ahead and put it in a different color so you know that it matches. There you go. And then quartile 3 is 17 minus quartile 1, which is 14. And again, I'm only going to put into my calculator the expression on the right side of the inequality. So 14 plus, oops, I forgot my 1.5. Have to copy the formula properly if you're going to want to get the correct answer, 1.5 plus. All right, so 14 plus 1.5, open parentheses, 17 minus 14, close parentheses, enter. So I got 21 is greater than 18.5. Is that a true statement? It is. So 21 is an outlier. So that's number 1. All right, I'm going to switch to blue here. All right, let's write all of these in order from least to greatest. It looks like 30 is my first number. And then 49. Nope, 48. And then 49. 50. 2 51s. And then 2 52s. All right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. There's your median. I'm not interested in the median, so I'm not going to figure that out. But here is my quartile 1. And it's going to be halfway in between 48 and 49. So it's 48.5. Here's my quartile 3, which is halfway in between 51 and 52. So it's 51.5. All right, so now we need to look at this. Do I think there's any outliers? Well, 52 is definitely not an outlier, right? If there's any outliers, it's going to be 30, so that's at the lower end. So 30 is less than quartile 1, which is 48.5 minus 1.5 times quartile 3, 51.5 minus quartile 1, 48.5. Again, what am I going to plug into my calculator? Just this expression right there. So 48.5 minus 1.5, open parentheses, 51.5 minus 48.5, close parentheses, hit enter, and I got 44. Is 30 less than 44? And it is. So 30 is an outlier. There we go. All right. So that is the end of our lesson today.